In this video, we will look at the substances or agents added to bitumen to enhance properties like viscosity and adhesion. The cutter in cutback bitumen only creates a temporary reduction in the bitumen's viscosity. The bitumen goes back to its original viscosity as the cutter evaporates out of the mix. The increase in the bitumen's viscosity results in a loss of flexibility. Fluxing agents can be added to the bitumen to create a long-term increase in the bitumen's flexibility. This allows us to increase the long-term flexibility of the bitumen without using a softer binder which has a lower viscosity. In other words, the bitumen is more flexible, but it is still harder. The most common flux used in New Zealand is automotive gas oil, or AGO for short, which is basically just diesel. Fluxes or fluxing agents are added at about 4% of the bitumen weight, but much of that evaporates off during the laying process, so approximately 1 to 2% remains in the bitumen to provide higher viscosity and more flexibility in the long term. Heavier oils can be used which remain in the bitumen for a longer period of time. There needs to be good adhesion between the surfacing aggregate and the binder, especially for chip seals. If the binder is not strongly adhered to the chip, then the chip can be stripped out of the binder by traffic loadings, especially horizontal loadings that occur when vehicles are turning, braking, or accelerating. In addition, water on the road can be pumped into the pavement by traffic, creating pressures at the interface of the chip and the binder that can erode the connection between them and result in the binder being stripped from around the chip, which ultimately results in the chip being stripped from the road surface. Water on the chip can reduce this adhesion, so the chip needs to be dry and clean when laid. However, there is often still some water particles present on the chip surfaces, and these can reduce the adhesion between the chip and the bitumen. Adhesion agents increase the adhesion between the binder and aggregate particles. They do this by increasing the bond between the aggregate and the bitumen, displacing surface water on the chip surface, and reducing the surface tension of the bitumen to allow it to better coat the aggregate particles. The addition of polymers changes the properties of bitumen to make the binder more elastic. That is, it can flex slightly under traffic loads and then bounce back to its original shape without cracking. Road surfaces compress a few millimeters each time a vehicle passes over them and need some elasticity to bounce back to the original shape. In addition, horizontal loadings caused by turning, braking, and accelerating can induce some horizontal flexing as well. The increased elasticity of the binder, enabled by the addition of polymer, makes the road better able to flex without cracking or breaking up. The resulting mix is called polymer modified binder, or PMB for short. Different types of binders can be added to a bitumen emulsion as well. The resulting mix is called polymer modified emulsion, or PME for short. Polymers are substances made of many molecules all strung together in a chain and are very common materials. The polymers used in PMBs are plastic or rubber compounds. For example, an early polymer used in PMBs was latex rubber, which explains the elastic properties that polymer can produce in a binder. More polymers have been developed since then, so latex rubber is only used in emulsions. PMBs are used in areas where extreme temperature and for highly trafficked roads. Cold conditions can make the bitumen harden and become more brittle. As mentioned, road loadings cause the binder to flex slightly, and if it is too brittle, then it will crack. The additional elasticity provided by the polymer enables a cold binder to flex without cracking. Heavily trafficked areas require the binder to flex more often as each vehicle passes over it. This repetitive flexing can result in the binder eventually losing its elasticity and cracking, in the same way that a piece of wire will break if you bend it too many times.